How you doing, Guy? How you doing, Josiah? So yeah, today's day 2 of glaciers. We do have a glacier web quest that we're going to be getting at the towards the end of the mini lesson. What's the code? Oh, you're using a iPad. It's JM. Here, I'll type it out. It's JMW JBS. That's the code.
Good morning, Marie. Oh, Shanice's here.
Hey guys. Hi, Jennifer. All right, we're just getting started on the do now. But for those of you that just joined us, students will be able to describe how glaciers move and change over time. Do now says, using the Pear Deck link in the chat, answer the following by writing for 3 minutes. You got a 3-minute timer on the board. And please do not forget, you need to include your name. If you don't write your name, I don't get to see whose lovely idea that was.
You guys remember, you're just predicting, so everyone's response is going to be different. Don't overthink it. Just think about it in real world. So if all the glaciers were to melt, what do you think will happen? All right, we're seeing some really good responses so far.
Oh, that's right. You can see the student answers now.
Right. I love the co-teaching feature. I'm still trying to navigate it, though. All right, so Christina, it looks like she's done. She said that certain parts of the world would be unrecognizable, would have extreme weathering and erosion. Excellent. Abdullah said it would cause a massive increase in the sea level, okay, so sea level rising. Okay.
Christian said the water temperature would decrease the temp to the water forever, or at least temporarily, and the direction of water flow may change. So Christian touched on something very interesting. I guess this will be when we get into weather, we'll talk a little bit about the global conveyor. Just like a conveyor belt moves packages around a factory, the oceans move warm and cool water around the planet. And if you dump a bunch of ice cold fresh water into a salty ocean that is relatively warm, maybe about 40 degrees Fahrenheit, you're going to break down that conveyor belt. We'll talk more about that, but very, very good point, Christian.
See a lot of people touching on sea level rising, which would be a major problem. Yes.
Okay, I've got 14 students in the room, and I only have, what is this, 7, 5, 6, 7, 8 people? Come on, guys.
I'm going to post a link in the chat again. If you haven't connected, please join.
Indira. Question, do we use glaciers as a water source? You can. I don't know of anybody that does, but...
Right, but a lot of the world's fresh water does come from our glaciers.
You know, I'm sorry, I misunderstood your question, Abdullah. I thought you meant like literally chiseling it out of the glacier and melting it down. But no, the meltwater that comes off of that does feed many streams and tributaries. And yes, it does contribute to our freshwater intake. All right, so a little bit of review from yesterday. What exactly is a glacier? Glaciers form wherever snowfall exceeds snowmelt. You're going to get an accumulation of snow as long as the temperature is cold enough. And then that snow will then compact and harden and become this bluish white ice we call glacial ice. Currently, about 10% of the Earth's surface is covered by glaciers.
All right, and to review our glacier types, we know we have 3 main types: continental, valley, alpine, or ice caps. Continentals, we know, are large ice sheets that cover relatively flat land areas. The valley glaciers, we know, make its way from the mountaintops down through the valleys. And then ice caps are basically larger glaciers that cover areas that are larger than a valley.
So yesterday, you might have remembered we took a look at Google Earth and we saw how the North Pole, even though it's got an ice cap on it, it's not represented on there because there's no land at the North Pole. That would be more ice cap than continental ice sheet. We refer to continental ice sheets as the ice sheets that are on, well, a continent. So really, it's restricted to Greenland and Antarctica, the bottom of the planet. So glaciers, where are they? Once again, about 85% are in Antarctica, about 10% are in Greenland. But a little bit of review from yesterday. So we have two environments here. I want you to grab the check mark and drop it off on the spot that was carved by ice. You've got 30 seconds. You feel your heart racing? I feel mine.
No.
I hope that's a suspense and it's not heart failure.
Oh, goodness.
15 seconds.
Come on, guys, need everyone to respond.
Yeah, I'm waiting on a few more. All right. Fingers crossed. You guys got me a little bit nervous.
Right.
Sure. Oh, it's like half and half. Okay, so if you take a look at the one on the left, we've got this long, wide, swooping U shape. Remember, the U-shaped valleys are caused by glaciers, where these sharp V shapes, watch me unlock it, where these sharp V shapes are rivers. Yeah, I was waiting for all the arrows to move over the check marks.
All right, let's have one more try at this. So today we're going to move on to glacial movement, right? So we learned how they formed yesterday. Now we're going to talk about how it moves and changes as time goes by. So let's have your take on this. What could be possible causes of glacial movement? So why do you think glaciers move?
Yeah, so there are a lot of reasons. Reasons that they move. The amount of ice. I don't know. This is an older version of the PowerPoint. I don't know why it's not updated, but I tweaked this a bit. It's supposed to say the mass of the ice. That's really the big driving factor. The more ice you have, the more mass. The more mass, generally gravity is going to be pulling on that, and it's going to be sliding down the mountain. The steepness of the slope. All right, so we referred to the continental ice sheets, which are relatively flat. Now, it's not 100% true. Right, the middle of those continents is higher up. This is why the ice does flow away from the center. But it's much more pronounced with those valley or alpine glaciers. Yeah, we call this movement flow.
All right, and if we were to look particularly at a valley glacier, we might see it again being driven by gravity. So it's moving downward from the mountain, right, down through the valley. So it's downward movement. Or it might have a sliding along its base. And we might see a lot of crevasses being formed within these valley glacial movements happening. We also have ice sheet movement. When that happens, it's pretty much moving downward and outward from high elevations, trying to make its way down to like the ocean fronts.
So glaciers become thinner as they move lower due to melting and evaporation. Worldwide glaciers have receding ice fronts, and really, it's just the lowest spot that the glacier comes down to. That's the point we're going to see the most melting. Now, why is that? You can think of the Earth's atmosphere like a series of blankets. The closer you are to the surface, the more blankets you have on top of you. So generally speaking, the lower your altitude, the lower your elevation, the warmer it is. So warm air and ice typically don't go together, and then we get events like this. And we're going to have to watch an ad, I'm sure. Hey, no ad.
The whole vast river of ice is on the move, slowly toppling into the sea, sometimes in small lumps, sometimes much bigger ones.
Okay, I'm actually going to fast forward
Given
a
that
bit.
fact,
So these guys got into a boat. They went right next to a glacier. Of course, the engine on the
How high do you
boat
reckon
stops
that is?
working.
40, 50 meters?
For about 1:15, it shows you the actual housing breaking away of the roof, guys.
Now, this is normal. This is natural. This happens even if global warming wasn't a thing. The issue is that climate change
That is
is
an enormous
accelerating
drop right at the
the
top.
speed at these glaciers are calving and breaking off.
That whole front is going to go at some point.
You hear it cracking. All right, time to leave.
Right.
All right. So we have. Let me stop presenting. We have this
Good.
video here
Gotcha.
that is available for you on our Google Classroom. You can watch the entirety of that if you're interested. We also have another one here showing more sea ice, but I'm not going to take the time to show that. You can watch that at your leisure. One thing that calving ice does provide is habitats for creatures. So here we got a polar bear, and being an aquatic mammal, essentially they live in the water. The ice definitely serves as a habitat for them, a place for them to stay. Fun fact, you ever wonder why polar bears don't eat penguins? They're on
Let's see if
different
anyone.
sides of the planet. All right. Earth's glacial past. Question. What percentage of the Earth's land area was covered by ice? Penguin too fast. Penguin too fast, too furious. What percentage of Earth's land area was covered in ice during the last ice age? Place a dot over the correct answer. So, absolute total guess. Think about what you've seen in the cartoons from the last ice age. What do you think? 30%, 50%, or 70%? Just so you're aware, about 500 million years ago. So this is like not the last ice age by any stretch. This is a long, long time ago. The last ice age was about 20 to 30,000 years ago. But the last massive ice age that we had about 500 million years ago covered pretty much 100% of the planet. So what do you guys think?
Nice. So we're all over the place.
Okay, let's take a look.
We need 5 more responses, guys. Come on.
All right, if you take a look at my screen, I'm sharing it. I think a lot of people are saying 70. A decent amount are in the middle, and some are saying 30. Well, the answer is 30%. Nice, Abdullah. Miss G, you want to do this slide?
Yep, we got this one. All right, so glaciers of the past, right? So actually, it is 30% of the land that was covered by glaciers back in the Ice Age. And we know this took place between 2 and 3 million years ago, and which actually took place within the Pleistocene epoch, which you guys hopefully remember when we covered Earth's history. So these were the woolly mammoths that were walking the Earth's surface during that time period.
You're reading my mind, Miss G. I'm pulling up my reference table right here. When was the last ice age? Well, if you take a look here, maybe I could zoom in a bit. What did it say on the slide? It said during what era? I'm sorry, what epoch?
Pleistocene.
During the Pleistocene, right? So if we take a look, Pleistocene is right here, and it says humans, mastodons, and mammoths. Yeah, so that really wasn't that long ago. It's somewhere in between 1.8 million years ago and 0.01 million years ago. And again, that's about 20 to 30,000 years ago. We're ballparking in here. The reference table isn't that accurate with it. But one other thing I do want to remind you of is on page 9 on your reference table, important geologic events, advance and retreat of last continental ice. That was the last ice age.
All right, so we talked a lot about glacial movement. How about let's talk about the speed. So how quickly do our glaciers actually move? So they actually move very slow and steady, about a few tens of meters per year. Sometimes we do have surges, and so they may move a little bit faster, maybe up to tens of meters per day. but that's really not the norm, usually very slow and steady. And we do have very slow movement at the base and faster movement at the top, which is because of the elevation coming downward mostly.
I'm going to skip crevasses in this one for a minute. I want to show you a video of a Chilean glacier advancing and retreating. So these researchers took a camera and set it up and basically took a picture every day for a year. And you can watch the advance and retreat of this glacier, sped up. So you can see in February it was to here. By March, the edge of the glacier is right about there. And you can see as the months go on, the glacier is still sliding down the mountain, but it's actually retreating up the mountain at the same time. The actual ice is sliding down, but that boundary layer, that ending layer, that termination layer, whatever you want to call it, that actually goes up the mountain as the months go on. And you can see by September, quite a bit melted away, and by January, there's a lot that is gone. But then by January and February, all of that will be built back up. So we get a surge where it builds up, and then we get most of the year where it's melting away. Okay, let's head back. This is really kind of a review of yesterday. We mentioned crevasses. On here it says it could be over 150 feet deep. Those cracks, yeah, they can be that deep, and that's really for valley glaciers. When we start talking about continental glaciers, they can be much deeper. But this is generally from when the glacier rolls over something, it's going to get the cracks on the top.
Right, and like the video we just looked at showing advancing and glacial retreating, where you think about advancing glaciers, remember that's moving in a downward direction, so downhill. We have the ice front moving as the glacier is also growing as it's moving. And then if it's retreating, it's also moving downhill, but the ice front moves in an upward motion because it's melting. So those are two differences.
All right. And, oh, come on, my GIF isn't working.
Oh.
This is showing temperature changes over time. The globe was supposed to spin, and you were going to see how the planet is getting warmer. But that is it. We do have an exit slip. Don't start on that yet. I do want to show you what today's activity is. So we're going to go to our Google Classroom. We're going to go to classwork. And you have two things on here. You have the notes from today. This was the document we were just looking at. And then you have your Glacier Web Quest. You're going to click through this. And kind of like how we've done before, you have your link to your web addresses. And then you have these little red text boxes where you could click on them and type your answer. So if we go through to this, this brings you to the National Snow and Ice Data Center. On the left-hand side, you have a bunch of these links. You need to navigate. You need to search through these, read through the articles. They got some pretty cool pictures in here as well, and try to answer the questions that we've created for you. Due date on this? I don't remember what I put it as.
Thursday, probably.
Thursday.
And guys, don't overthink it. This is just meant to extend your knowledge from what we learned yesterday and today, just to give you some additional background and some facts.
All right. And before we leave, you have an exit ticket. Include your name. If your name is not there, you do not get credit. Pick one of the two. Only one of the two. Question 1 says, explain how erosion takes place as glaciers move through a landscape. And number 2 says, in your opinion, how can humans stop glacial melting? Why or why not? Explain using details. All right, I'm going to throw a 3-minute timer on here. When you're done with this, if you have any questions for myself and Miss G, we're going to be hanging out here for at least the next 15 or 20. But that is it, unless there's anything from you, Miss G.
No, that's it. If you need one-on-one support, just please stay on, and we can help you.
Super.
Otherwise,
bye, LaSheila.
Put your exit slip and continue working on your classwork, and have a great day. If you don't have any questions, guys. So everyone's tackling the humans can stop glacial melting question.